Good afternoon, everybody. I'm Lynn Rubenstein. I'm the Executive Director of the Northeast Recycling Council, and I'm delighted that you're with us this afternoon for this webinar being co-hosted by NERC and NMOA. The topic is Achieving Net Zero in the Solid Waste Industry, and we have three outstanding presenters who you'll be hearing from shortly. I would like to thank and acknowledge our sponsors, who are Quantum Biopower, Tomra, and Vanguard Renewables. And I need to do some exciting housekeeping. So we are going to hear from all three presenters before we take your questions. But we most definitely want you to be posting questions, and it is posting your question. So to do that, if you're not familiar with the GoToWebinar platform, on the right-hand side of your screen, there's either a little dashboard showing up or a little orange arrow showing up. If the dashboard's not there, click on that orange arrow and the dashboard will open up. And then you'll see that one of the choices is questions. And you click on that, and then you type in your question and hit return. So Terry is going to be monitoring the questions, and she will be facilitating the question and answers after we've heard from all three of our webinars. I also want to point out that the webinar is being recorded and that all of the presentations will be posted on the NERC website by tomorrow, along with the webinar recording, and they will also be posted on the NMOA website. You will receive an email with a link to access those. Now, with that, I'm going to introduce our speakers. First, we will hear from Anne Germain, who is the Chief Operating Officer and Senior Vice President of Regulatory Affairs for the National Waste and Recycling Association, NWRA. She is responsible for establishing and implementing strategies for recycling, landfilling, and sustainability in accordance with their member needs. Her 30+ years in the industry includes extensive background in the analysis of industry trends, contracting, engineering, operations, and compliance. Before joining NWRA, Anne was Chief Engineer for the Delaware Solid Waste Authority. She is the past president of SWANA and serves on the executive committee of ABET. She is a professional engineer and a certified environmental engineer with a Master in Civil Engineering from the University of Delaware and a BS in Civil Engineering from Virginia Tech. Next, we will hear from Abby Webb. Abby is Casellis Director of Sustainability, responsible for leading the company's programs and engaging sustainability programs, and engaging stakeholders around the company's 2030 sustainability goals. She supports the development of services that help Casellis customers achieve their sustainability goals. Abby has been with Caselli for over 15 years. She holds a bachelor's degree in environmental geography from Colgate University and a master's degree in city and regional planning from Cornell. She is a master composter and is certified to support and implement zero waste programs as a true advisor. And then we'll hear from Evan Edgar. Evan is the principal engineer and president of Edgar & Associates. He has over 30 years of experience in all aspects of solid waste management as a registered civil engineer who has advocated for green energy initiatives, compost market development, greenhouse gas reductions, and practical regulations in the front of legislative committees, regulatory agencies, and local commissions involving the collection, hauling, processing, and composting of urban, green, and yard waste. So I'm going to make Anne the presenter and remind people to please be posting your questions in the question box. And really glad you're all here. So thank you, everyone. And Anne, hopefully I'll let you know if you have a problem. I'll stay here and say you're great when it shows up. How about that?
Okay. Hopefully.
Almost there. Just need the slideshow view.
Yep.
Now, can you know to get rid of all that? There you go. Wonderful. Thank you, and take it away.
Okay, hold on. So are you seeing? Okay. Okay, perfect. So today I'm going to be focused mainly on landfills and greenhouse gas emissions, and I chose to, rather than talk about the waste industry as a whole, to focus on landfills because They are one of the larger sources and the focus of a lot of people. So let's start off and level set a little bit on greenhouse gases. Hold on, let me see how I advance. Okay, so everybody knows there's a carbon cycle that occurs. You know, we breathe in oxygen and breathe out carbon dioxide, and that's all been going on for the length of life, and carbon dioxide is part of that carbon cycle, and it's absolutely necessary. But then we have added a lot more carbon dioxide into the atmosphere through the combustion of fossil fuels, and as a result, we have increased carbon dioxide in the atmosphere through the addition of anthropogenic carbon dioxide, which has exacerbated the greenhouse gas effect. So we know through all this process that trees do pull carbon dioxide out of the air, but based on the latest numbers for what the average American emits or utilizes through their lifestyles and everything else, that it would take 1,000 trees planted every year for pulling 31 pounds out. So we need to look at this in a little bit more detail. So now let's look at landfills specifically. Looking at EPA, you can see that while the population since 1960 has gone up significantly, about 80% increase from 1960 to 2018, and you can see MSW generation also increased significantly over that time frame. Since 1990, the amount of material that actually ends up in the landfill has actually been pretty flat. But if you look at the composition of what is going to our landfills, that actually the current material has changed a little bit. Food is now the primary item in the landfill, that with plastics being number 2. And when we look at what's biodegradable, the 4 major categories are food, wood, yard trimmings, and paper and paperboard. So let's look at those and how they've evolved over time. As you can see, paper and paperboard used to be a significant percentage of the material that were in the landfill, but due to changes in behavior, people reading fewer newspapers, basically using electronic resources for instead of printing paper, the amount of paper has declined, but also a significant increase in the amount of paper recycled has also impacted the amount of paper ending up in the landfill. Conversely, you can see that the amount of food that has been going to the landfill has been increasing over that same time. Now, this is based on EPA's number, and EPA's numbers do use a top-down analysis, which basically estimates the amount that's generated across the country based on sales, and attaching usage figures, and then assuming that there's an amount that ends up in the landfill. But if you look at landfills and state waste characterization studies, when they do bottom up, and this is actually kind of the practice of digging in to the waste and trying to normalize it over a certain area, looking at it over multiple seasons, the numbers are a little bit lower. You can have, these are pretty much almost never done across the US, and they're very expensive because you're digging into it, but various states do these with some degree of regularity, and you can see from this that the numbers, Connecticut was fairly close to what EPA had, but the numbers could be as low as Wisconsin's numbers that they reported this past year of just 14.1%. And I did just focus on characterizations from the last 10 years because obviously we know that this changes over time. Okay, so looking at the way landfill gas, which is the primary way material gets emitted, landfill gas is basically we generally say about 50-50, 50% methane and 50% carbon dioxide. And because methane is a more potent greenhouse gas than carbon dioxide, even though it is part of the original carbon, it's basically biogenic material that is degrading in the landfill, but it's not degrading as CO2, therefore it's considered an anthropogenic source. So then you have methane production. And if you look at things from the beginning, like 30 years ago, landfills used to just vent their landfill gas. So this was actually designed into landfills. There would be pressure buildup in landfills, which was undesirable. So rather than allowing that to happen, the gas used to be just vented. And on the photo here at the left, it looks like it's a little bit more engineered, but those are still vents, and basically those whirligigs at the top spin around and kind of distribute the gas so that the odors aren't as bad, but certainly sticking with pure venting without any collection or control. But then in 1996, EPA did establish the new source performance standards, which required landfill gas to be collected and controlled if you generated more than 50 megagrams per year in non-methane organic compounds. And that's important because at the time it wasn't methane that was being regulated, nor the carbon dioxide that was being regulated. It was the non-methane organic compounds. And I'm already contradicting myself, because earlier I said that landfill gas is about 50-50 carbon dioxide and methane. So what are these NMOCs? Well, the NMOCs are a very tiny fraction of the landfill gas, about 1% or so. But it gets destroyed when it goes through a flare, and the methane is the fuel that's used to fuel the flare to destroy those NMOCs, and methane basically was used as a surrogate to determine how well landfill gas was being controlled. And then, of course, more recently, EPA did enact subpart XXX, which reduced the NMOC release to 34 megagrams per year, which they anticipate would reduce the emissions for methane by 24 million metric tons per year of carbon dioxide equivalent, which is about a quarter of total landfill methane emissions. The reason EPA didn't regulate methane or carbon dioxide was because they frankly felt that it was all, carbon dioxide was a natural gas and it wasn't an air polluting gas. And Massachusetts ended up suing EPA along with 11 other states in the late 90s, and went all the way to the Supreme Court. And then the Supreme Court found in favor of Massachusetts that said that yes, EPA needed to establish whether greenhouse gases were endangering people, and therefore if that were the case, then they should regulate greenhouse gases as air pollutants. At which point EPA did do that, and then they got sued by a bunch of other states, went back to the Supreme Court, but that was upheld in 2012. So now even methane and carbon dioxide can be regulated. But nonetheless, greenhouse gases from landfills have been regulated since 1996 through an SPS regulation of the NMOCs. And then landfills have to determine the amount of gases that they emit, and they do that through the greenhouse gas inventory. There is a greenhouse gas reporting program which requires sites of a certain size to actually report emissions from each of their individual landfills, and that's site specific. And then EPA takes that information and applies a scale-up factor to account for non-reporting landfills. Most of you know that landfills are the third largest source of methane emissions by category. But methane emissions are only about 10% of greenhouse gases. And in the inventory, EPA normalizes everything to CO2e, which is carbon dioxide equivalent. So they apply a multiplier for all the other greenhouse gases, depending on how potent they are. So for methane, I think it's 25. For nitrous oxides, it might be 300, and fluorinated gases, it might be up in the thousands. But then they bring everything to an equivalent, and carbon dioxide is still our largest greenhouse gas, making up 80%. And so of the 10%, landfills are 15% of that 10%, so less than 2% of the actual greenhouse gases. So as I said, population has been up about 30% from 1990 to 2019. Landfill tonnage is flat, but our landfill gas emissions are actually down by about 35%. So that is because of the NSPS and the regulations requiring collection and control. So a lot of that are landfill gas emissions are controlled. But in order to control more, before we can go there, we have to really understand how emissions are determined, because landfills are area sources, and the emissions for the most part are considered fugitive emissions, and there's no real direct measurement of them. Instead, they're estimated, and they're estimated using two different methodologies. There's a top-down where you basically take amount generated and subtract out what's recovered, and then there's a bottom-up, which then just looks at the amount you recovered and applies a collection efficiency. So let's look at generation real quick. Generation is a pretty rough guess also. It's a function predominantly of the amount of waste, the percentage of degradable carbon in your waste, your climate, and then the decay rate for the different carbon quantities that you might have in there, which could be very different. So for wood in an arid region, it could be as low as 0.02 K value, which would say that half the carbon would be gone in about 34 years, or as high as 0.185 for food and sewage sludge, which says about half the carbon would be gone in about 4 years. Looking at the bottom-up method, there's a collection efficiency that EPA dictates, which is based on cover. And what this means is that since it's based on your actual recovery, which then the collection efficiency is determined on, if you were to collect more, the more you collected, the more you would emit. And this is counterintuitive, but there's no kind of time off for good behavior. Like if you were to do better, your emissions would go up. And you might think to yourself, well, there's two actual collection formula. There's the top down and the top down and bottom up. But EPA says to use both and to take the higher number and report that for your emissions. So that restricts your ability to really show any reduction. And then there's like other things like methane oxidation. So EPA is pretty prescriptive in what is allowable. They default at 10% and give you opportunities to go up a little bit if you meet certain cover and flux requirements. But based on field measurements at different locations, the averages tend to be 30 to 40%, with really high levels up to 100% oxidation. And this isn't generally accounted for in any of the inventory. So your actual estimates of emissions, since they are estimated rather than measured, could be off significantly. Now, recently there have been some flyovers, and I'm sure a lot of people have seen references to landfills as super emitters. So NASA's JPL has been conducting some flyovers. These provide a snapshot of emissions at various point sources, which then they extrapolate out for a year and then say that, okay, these are the emissions. Right now, there's very limited data, and so the extrapolations for a single snapshot over a year is really questionable. But in 2023, we anticipate that the Carbon Mapper project, where a bunch of satellites will be launched, will give a significant increase in the amount of data. So there will be much more regular measurements of carbon emissions or greenhouse gas emissions from various sites. And obviously some of the states are doing this as well. Looking at this in a little bit greater detail, the California Methane Survey actually looked at 436 landfills, which they found plumes in 32 of them, so fewer than 10%. And they were able to go back to some of those facilities and find that the sources of those emissions were related to construction of new wells, gaps in intermediate cover, and leaking gas wells. And at the very least, we should understand that construction of a new well would be a very intermittent emission, but which shouldn't have been extrapolated out of the whole year. But you know, these are points that as you get more and more flyovers would end up getting addressed. The rest of the sources that were largely undetected, they suggest that those facilities emit methane as area sources, and what we suggest could possibly be that a lot of that material, methane, was oxidized to a point where there really was no emissions or insignificant emissions. The landfill gas that is collected can also be utilized, which would also have greenhouse gas benefits because they can displace non-renewable fossil fuels. And so EPA has identified a 3-megawatt project as being having certain environmental benefits, including sequestering carbon or avoiding 830 rail cars of coal burn, you know, et cetera, et cetera. Right now, not all landfills are doing utilization. The EPA has identified 548 active projects, but there's 483 candidate landfills that they think still have the opportunity to take the landfill that they might currently be collecting and just burning through the flare, and perhaps have the opportunity to utilize that as well and offsets other carbon emissions.
And I'm sorry to interrupt, but you just have a couple more minutes, please.
Thank you. Thanks. There's also sequestration of material. EPA's greenhouse gas inventory does acknowledge that solid waste disposal systems are responsible for sequestering about 69 million metric tons per year of carbon dioxide equivalent. And these show up in the inventory as a negative number. So landfills are pretty good sources of sequestration for the actual physical carbon. But not just that, there's opportunities in the future to collect carbon dioxide as a gas from landfill gas to energy or landfill gas control facilities, and perhaps sequester that in the future. Looking at organics, you know, not all organics degrade equally. You know, everybody knows that, like this thing up in the upper left, that was a baby mammoth that was recovered from like the ice. There's a bog man that was that's a pH related. You know, they have these mummies from thousands of years ago that were from very arid region. And this one in the bottom left, somebody apparently had a McDonald's hamburger that was 20 years old. I question that, but supposedly they claim. So, you know, obviously preservatives, sugar, salt, a lot of them will preserve foods and keep things from degrading. And even within landfills, there have been landfills that have been dug up for many years that have shown that a lot of material that doesn't degrade. So, you know, just kind of going back to some of the estimates might be significantly off. As stated, I used to work for DSWA, and we did some time capsules where we buried some material in our test cells in 1990 and extracted them in 1998. One was wet and the other one was dry, and you can kind of see from the wet cell, we did have significant degradation of a lot of the organic material. The environmental scientist wasn't really willing to dig into that, but he did pull out the bone. This is all from film photography, so some of the quality is not as good as you might have today. But from the dry cell, you can see things didn't really, not much happened there. And we have this chicken leg that pretty much looks almost edible, that shows that some of the organics really don't degrade, over time in a dry location. So if we want to move towards net zero, we can always reduce organics from a generation perspective overall. But we need to also focus on continuing to improve our landfill gas collection system. As the flyovers have demonstrated, we need to really focus on reducing emissions from construction activities, cover and leaks, and be more active about attacking those areas. But we also need to look at improving our emissions calculations, perhaps re-looking at the methane oxidation estimates and the K values. And NWRA is continuing to work with consultants and regulators on that. We need to continue to improve landfill gas utilization and improve sequestration of carbon and carbon dioxide. So thank you.
Color me impressed. 1 minute over. Thank you, Anne. That was very comprehensive. Lots of questions are coming in, as we would expect and hope. So I'm going to say thank you again to Anne and ask Abby, I'm going to make you the presenter, and remind people that to continue to post your questions in the question box. Thanks, Abby. And we can see your screen perfectly.
Wonderful.
Thanks.
And you can hear me?
Yes.
Right? Okay, great. Well, Anne, that was truly impressive. You covered a ton of territory, and I'm excited to follow you. I'm hopeful that what I'm going to show here will complement and sort of build off of what you just showed. So thanks also to NERC for hosting this webinar. This is a topic that's near and dear to my heart. I have to say, when I started looking at back in the mid-2000s, there weren't a whole lot of solid waste climate nerds for me to hang out with, so I'm excited to see more folks jumping in. It's not as lonely as it used to be. If there's one thing that you all take away from my talk today, I hope it's this. I hope that you take away that our industry already has a net climate benefit. And just as importantly, we should be proud of that, but we're only getting started. By helping our customers take their waste reduction and reuse and recycling work to the next level, we're in a really key position to help achieve global climate goals. So I'm hopeful that I can persuade you of that here today. So first, for those who don't know us, a little about Casella. We are a vertically integrated solid waste and recycling company located in the Northeast. We were founded in Rutland, Vermont in 1975. We grew from a single truck operation to where we are today, $800 million a year in revenue, operations throughout the Northeast, customers throughout the country. We're pushing 3,000 employees now, and we service hundreds of thousands of customers, ranging from individual households all the way up to college campuses, hospitals, industrial manufacturers, and so on. I'm proud to say that we recover over 1 million tons per year of recyclables and organics. And that number is growing. I'm also proud to say that we have already cut our carbon emissions company-wide by over 50%, and that number is still coming down. So I'll talk more about that here soon. A little background on our climate commitment. So we have been measuring our carbon footprint since 2005. We did that as part of the EPA Climate Leaders Program. That was a voluntary industry government partnership back at that time that was just starting to sort of dip our toes into the water of, how are we going to measure these emissions, and then what are we going to do about them? I'm proud to say that we were actually early adopters here. We were the only solid waste and recycling company to volunteer in that program. By 5 years later, we had actually reduced our emissions to 45% below our baseline. We achieved our first goal, and we were actually recognized in 2012 with a Climate Leadership Award from the EPA and some environmental nonprofits. Fast forward again, 2020, last year, we began disclosing our climate strategy and our thoughts about risks and opportunities through CDP. And we announced 2 new climate-related goals. The first was to continue our reduction of Scope 1 and 2 emissions. We aim to reduce to 40% below 2010 by the year 2030. And then we also committed to improve our net climate benefit factor to 5x by the year 2030. And I'm hopeful that by the end of this talk, you'll understand what I mean by that. So I'll get us started. We'll start where we started, which is in measuring our Scope 1 and 2 emissions. For those who don't speak the lingo, Scope 1 refers to the direct greenhouse gas emissions coming from our operations and so the facilities we run and the vehicles that we own and run. And then the Scope 2 emissions refers to the electricity coming from, the emissions associated with the electricity we buy. So technically those emissions don't occur on site, but we do have a lot of control over how big or small those are through our purchasing and through our use of electricity. So here's what Scope 1 and 2 looks like for Caselli. 85%, so we're talking 569,000 metric tons per year of CO2 equivalents. That's our entire company footprint in the Scope 1 and 2 category. 85% is coming from our landfills. 13% comes from mobile combustion. That's our vehicle fleet, the trucks that we have running around and the operating equipment at our facilities. And then the last 2% is our stationary combustion and electricity from the facilities that we run. Sidebar, like our MRFs, which are processing all those hundreds of thousands of tons, those are in the 1 and 2% category, just for context. So for a company like us, looking at an inventory like this, here are the types of things that we're doing to lower those emissions and that we've been doing for the past 15 years. A big piece of it is we've got to capture that landfill gas, right? So it's been about installing horizontal and vertical gas collectors, tuning those well fields, thinking really carefully about the design and the timing of our capping systems. And all of that is to make sure that we're collecting as much gas as possible. And I will say, Anne pointed out some of the trickiness of the EPA models. We are somewhat victim to that formula that says the more gas you collect, the more it looks like you are emitting. But it's the best model we have available today, so that's what we go with. But it is a little bit, when you dig in deep into the details, sometimes it feels like it's telling you the wrong thing. On the fleet side, we've done a lot of work with routing efficiency. We continue to do work there, as well as alternative fuel vehicles. So we have a number of compressed natural gas trucks in our fleet, and then we are just getting started with electric vehicles. We have a pilot starting right now with 2 EV trash collection trucks. And then we're not ignoring our 1 and 2% of stationary combustion electricity emissions. We do have a number of energy efficiency projects that we've deployed over the year to tackle those, although they're not quite as impactful on a grand scale. We still pursue those. So we're really proud of the reductions that we've achieved through activities like this. It's important work, and we're glad to be doing it. But I couldn't help, as a young employee of Caselli, environmental manager all those years back, it just, it felt like we're missing a critical piece of the story. So what's missing? As we look at those strategies that we use to reduce our emissions, we didn't talk at all about the 600,000 tons per year of recyclables that we're capturing and returning to the economy. We didn't talk at all about carbon sequestration. And here I'm referring both to the carbon sequestered in the landfill, which Anne spoke to a little bit, but also the carbon that we return to soil every year through our organics recovery activities, 400,000 tons per year of that. And then lastly, the renewable energy production. We do produce 87,000 megawatt hours of electricity from the power plants that we own, and that's not captured in there either. So I think, another way of looking at it is Scope 1 and 2. I don't know if you can see my cursor, but I'm pointing to this graphic here, which shows the life cycle greenhouse gas emissions associated with materials management. So in other words, this is the stuff we buy and consume where do the emissions come from? And I looked a while back at an EPA study on this, and I found that about 5% of the full life cycle emissions came from end of life, and 95% was all the emissions that happened before it ever showed up at the curb, basically. So when we talk about our scope 1 and 2 emissions, we're only looking at 5% of the impact of the materials. When we start to look at our recycling activities, our organics recovery activities, and energy production, we're talking about basically leveraging our role to cut short some of these supply chains and reduce the 95%. And so that's really the opportunity here. When we start to influence materials management in a way that cuts these supply chains short, reduces extraction, reduces mining, reduces transportation, then we can have an amplified impact on benefiting the climate. So I wanted to, we manage what we measure, right? I wanted to find a way to start to quantify that. And there was no sort of official, off-the-shelf methodology for doing this. We had to do the best we could with the data available. So I think this will be my little disclaimer. What I'm about to show you is by no means like an approved or certified approach to measuring emissions from our industry or measuring the benefit. I think we have some work to do to get folks to recognize it this way, but for now, this is how we're thinking about it, and I think this is one of those things where we want the metrics to push our actions in the right direction, and I feel confident that this approach is pushing us in the right direction in terms of what we focus on. I'll explain that a little bit more. But so what I'm pulling up here is the net climate benefit factor calculation. You can find this if you want to read more about it. You can go to our sustainability report. If you go to casella.com/sustainability, you'll get there eventually. So let me just talk you through this. So we're looking, the numbers at the top, the units are million metric tons of CO2 equivalent. On the left-hand side, you're going to see the 569,000 metric tons of emissions that I talked about before, coming from our landfill, coming from our fleet, coming from our facilities. And that makes up the denominator of this metric. You can kind of see it down here, 0.569. The numerator, I took our recycling activities, our tonnage, multiplied those by EPA factors. I took some of our carbon sequestration activities, multiplied those by EPA factors, and then same took our renewable energy production, multiplied those by actually E-grid factors. Came up with these numbers up top, which add up to the 1.849 million metric tons of CO2 equivalent of emissions prevented or avoided or sequestered, what have you. It's good, doing the good thing to emissions. So if you take those two numbers and divide them, so 1.849 divided by the direct emissions, 0.569, you get a net climate benefit factor of 3.2x. And so that's essentially, we look at that and say for every ton of greenhouse gases that Casella emits through its operations, we prevent 3.2 tons of emissions throughout the economy through the work we do with our customers. And so we set a goal to increase that number to 5x by the year 2030. And we're going to do that in two ways. One, by reducing our denominator, reducing our direct emissions, scope 1 and 2. And then also by increasing the emission preventing and emission avoiding activities in the numerator of that calculation. So here we have, what I, as a young environmental scientist, wanted to see, which was encouragement within our climate strategy for us to pursue an advanced recycling, pursue an advanced carbon sequestration, pursue an advanced renewable energy. So I throw this up here so that the calculation you see here is incomplete, and I acknowledge that. It includes what the activities that I had readily available emission factors for, using the EPA WARM model and some of the other EPA studies, as well as E-grid factors. The items in gray here are the ones for which I didn't have good factors, or I don't have them yet, but it's in the works. We're going to be doing some LCA work. We got some started in the past year. We're going to be continuing that into the year ahead. And that I hope is going to be able enable us to build this calculation out a little bit more and even more thoroughly document what we're doing and what we can be doing to work our way towards that 5x number. So why does this all matter? I think this is important so that, I didn't create this, put this net climate benefit factor out there just to sort of pat ourselves on the back. I really think it does matter. So, and here's why. Under a scope 1 and 2 focus, we would just spend our limited time and resources on emissions from landfills and emissions from trucks. And that's good, but it ignores the vast climate benefit that we can achieve by focusing on recycling, carbon sequestration, renewable energy, organics recovery, and so on. It's only part of the picture. And it's felt that way for a long time, and that's why I was super excited when I came across this 2019 report from the Ellen MacArthur Foundation, because it's literally called Completing the Picture, how the circular economy tackles climate change. And so I definitely encourage you, I've got the link there, I encourage you to download this report and check it out. There's some really interesting stuff in there, but the thrust of it is that right now, with the focus that we have on climate change globally, energy is in the crosshairs. It's the primary focus of all of our policy, but sort of the secret that people forget to mention is that energy only accounts for 55% of greenhouse gas emissions. And I mean, it's big, and we absolutely have to tackle it, but it's only half the story. So where's the remaining 45% coming from? It's things like resource extraction, land use practices, industrial manufacturing practices. And I feel that our industry is perfectly poised to tackle those through advancing what are being called circular economy principles. Essentially, the non-energy emissions are right in our wheelhouse, and we're well positioned to help tackle them. So, see if my little graphic here works. Yeah, so there you go. So we're in a position to bring in that other 45% of climate solutions that's going to allow us to really have a comprehensive climate strategy. I really believe that through things like, whether it's exactly the net climate benefit factor or something like it, I believe that when we measure and manage things the right way, recycling really is a clear and essential climate solution. And so, yeah, I hope I've brought you along for the ride. Again, I told you at the beginning that I hoped you would take away that our industry already has a net climate benefit. We should be proud of that. And we should be rolling up our sleeves because we're just getting started by helping our customers with their waste reduction, reuse, and recycling goals. We're going to be able to help achieve global climate targets and play an essential role in those solutions. Thank you.
Wonderful, Abby. Thank you so very, very much. And questions are coming in, but we invite more. And with that, we're going to turn to Evan, our final presenter for today. And Evan, you have been invited. There you go. Oh, it was perfect. Now it's not. You see it, but it's not in slideshow.
Can you see?
I see it, but it's not in slideshow. It was for that very first second. It was.
Is that now?
No, not for me. I mean, we can soldier through, but if you're able to get it into slideshow mode, that would be preferable.
Okay. Here I go. Slide. Okay. Well, I'm not used to this platform like Zoom, so I'm doing the best I can. But do you have my
slide? That's fine. We'll if you want, I can show your slides, or we're just fine like this. Your preference.
How about, let me see if I can. How about you show my slides?
Okay.
Well, thank you. Well, that was amazing presentations from Caselli about a lot of setup work. My name is Evan Edgar. I'm an engineer here in Sacramento, California, representing the California compost industry. And I'm a lobbyist for the waste sector for the last 30 years, private independent. We had this law signed back in 2006 by Arnold Schwarzenegger, AB 32, that set us in the course, and that's when we started measuring the carbon footprint. I measured the carbon footprint for over 100 companies. For over 10 companies for 100 years, been verified by the Climate Registry. And this new net benefit factor that Abby was talking about is great. Waste Management has it in their report, in their sustainability report for 2020. There are 3 times in 2020 with a moonshot goal to be 4 times net benefit or net zero greenhouse gases in 20 years. I'd like to see a lot of the Caselli numbers. There's 3.2 now with a goal of 5 times by 2030. Recology, which is a company out here on the West Coast, they posted their sustainability report at 8 times. That's the West Coast offense. And for the state of Washington, I did for the Washington Refuge Recycling Association, I did the state of Washington, and they're at 2.7 times net zero in 2017. And finally, I did the state of California, where in 2018 we were 3.7 times net zero in 2018, with a goal of being almost 10 times in 2030 with all the different programs you have. And you can't measure what you don't measure. So it's great we have a new measuring stick. I'm glad the solid waste industry embraced it, and I'm glad we have the tools in front of us to calculate these that can only get better with time. Next slide.
Evan, great. I was just going to say, be sure to tell me when to switch Ola. Thank you.
Okay. The next slide would be, we are in a wheelhouse of the circular economy. That's a new buzzword. Recycling was sexy, and then came sustainability, but now circular economy is every legislative piece we have. Circular economy is the buzzword, and we are in the wheelhouse of the circular economy. Out west, we have a low carbon fuel standard, which we can make renewable natural gas out of our biomethane that used to go to landfills. We can do it at wastewater treatment plants, standalone anaerobic digestion, dairies, and we have a lot of opportunity and a lot of incentives with a low carbon fuel standard that's really driving the program. On a federal level, they call it RIN, Renewable Identification Number, and that program is great. We're making our own low carbon fuel. We can make this carbon negative. We got about -100 as the average because we offset the methane at the landfill. We also have another program called the Biomat that takes renewable energy to the grid up to 3 megawatt. We have incentives to have pricing from 12 to 18 cents a kilowatt hour, which is great. The Climate Action Reserve has a lot of benefits on voluntary carbon offsets that from composting and AD, and a lot of protocols are being developed. But once they go from voluntary, they gain a lot of value and they go regulatory under the cap and trade program that we have in California that's supplying billions of dollars of incentive money to build this infrastructure, the compost facilities and anaerobic digestion. And then of course you have SB 1383, which is a law to divert 75% of all organics from the landfill by 2025. So, and we got net zero to kind of talk about all this. It's not really carbon neutral. We have a goal in California to be carbon neutral by 2045. A lot of blue chip companies on the ESG reports, environmental programs, that they want to be net zero by 2050. I'm going to go on and talk a little bit about the scopes 1, 2, and 3. Great job by Caselli, by the way, really putting things in focus. We go through the climate registry out here with regards to having our emissions verified for scope 1 and scope 2. And for scope 3, we use the same model, the federal EPA WAR model. So we talked about methane is direct emission, so it's from composting and from mobile construction and their fleets, but I even threw in shipping because we export a lot of recyclables. For scope 2 is indirect emissions from imported electricity, and scope 3, recycling, compost, and biomass combustion. Now the federal EPA WAR model includes embedded the fleet from transportation emissions and the shipping. They have some metrics, it's very deep. When I did California calculations, I just included it. I wanted a double counting. It wasn't federal EPA WAR model does not get into just aggregate the fleets and shipping. It's not transparent. So I decided to calculate it anyway and have that a metric, make it transparent, a rather double count than have it hidden. That's one big criticism of the federal EPA WAR model, that you can't really see the fleets and shipping emissions. Another thing we do, we use the California grid. When I did Washington, I use the Washington grid. Each state has a different carbon intensity for their grid as they go to carbon neutral by 2045. Or we have a renewable portfolio standard to be carbon neutral from renewable energy by 2030. So we have a lot of goals in California. And what happens in California doesn't stay in California. All these different programs are coming to Washington and Oregon for cap and trade and low carbon fuel, a lot of good incentives. We've been at it for a while. One thing we don't do as well in the California model, we don't count sequestering carbon in a landfill. Waste Management did, and most everybody counts that. I don't see carbon being sequestered in a landfill as a good thing. I think that we should take those nutrients and organic matter out of the landfill and make healthy soils. The soils in California are depleting down to less than 1% due to use, and by pumping compost and organics back into soil up to 3 to 5%, we a lot of co-benefits. So we do not count carbon sequestering as a benefit. Net zero greenhouse gas analysis. Next slide, if I forgot to say that. Are you looking at the net zero greenhouse gas slide?
No, we're at the gas emissions identification scopes 1, 2, and 3.
How about the next one? I forgot to tell you that.
Net zero GHG analysis. Yes.
Thank you. Yeah, every 5 years, our air board and do a scoping plan where we kind of adjust our way we define things. The scoping plan for 2014, actually 08, adopted a definition for net zero greenhouse gases for the waste sector. To achieve net zero, the direct greenhouse gas emissions in the waste sector would have to be fully offset by avoided greenhouse gas emissions. Avoided greenhouse gas emissions are reductions in a life cycle greenhouse gas emissions that would occur because waste is shifted from landfilling to alternatives non-disposable pathways. So that's defined in California. It's a great definition, and I really like what Abby did to really set the platform and being ahead in the Northeast to define your carbon footprint and use the WARM model, and we call it net zero greenhouse gases. Next slide, please. Going across the landscape, all the different scopes, I'm going to talk detail about, the direct emissions from landfills, from combustion, from composting, shipping, indirect, and then the offset or the avoided emissions are pretty large due to composting, recycling, and biomass combustion. That kind of gives a relative basis, and that's what Abby pointed out, where Caselli was 3.2 times net benefit. California as a whole, if you do the math on all that, it's 3.7 times in 2018 data, with a goal of getting to 10 times, 9.9 times by 2030. I'm going to walk through those goals and where we're at with getting to net zero 10 times as a goal. Not adopted by the state, it's just something I'm putting out there on behalf of the waste sector, because we get no respect. People think we do dirty diesel done dirt cheap direct haul to the landfill, and that's just yesteryear. That is so yesteryear, and I'm really glad Caselli stepped up with their metrics on the East Coast, and we're doing the same on the West Coast. Next slide, please. We have to reduce emissions in the landfill. Great presentation by Ann on I'm an all landfill engineer. I'm a manager of landfill operations back in the 80s and 90s, and what landfills do emit, and they're super emitters. In 2018, there was 8.7 million metric tons emitted from California landfills, with a goal of by 2030 to reduce that down to 3.7 times. That's 4 million metric tons of reductions, and that's basically coming from getting 75% of the organics out of the landfill. Food waste, green waste, compostable paper, wood, so some has different methane avoidance, another has different life cycle avoidance. So there's two different avoiding emissions, is what is methane, and direct emissions, what is life cycle, by getting the material out of the landfill, which is a scope 3 avoided indirect emissions. So we're on the pathway. A lot of regulations, a lot of people are repurposing their, they call it legacy landfill gas, and they're making RNG out of it, or going to the grid, but it's tough to get air permits. So a lot of landfill gas is being flared, but there should be projects. Great benefits for projects. The carbon intensity is down to about 34 on the carbon intensity scale, where diesel's 100. So it's a good opportunity to take the legacy landfill gas to do something with it. Next slide is all about composting, the scope 2 emissions. And the scope 1 emissions from composting. In 2018, emitted 0.4 million metric tons of CO2 out of landfills, but it was offset by all the benefits of sequestering carbon in the healthy soils in agriculture, by displacing fertilizers and pesticides, and reducing water by 30–40%. So, and then not put it in a landfill, so it's avoided emissions from methane. So it's about, you see that's about 4 times, and there's a net benefit there, but there are emissions from composting. By 2030, there'll be a lot more composting in California. We're going to dump $2 to $3 billion into infrastructure for to divert 75% of the organics. And by 2030, we're going to have almost 4 million metric tons of avoided emissions due to composting. So we have a lot. We just got $270 million in the budget this year to build infrastructure. So finally, with the program starts on January 1st, 2022, where you have to gear up to get 75% organics out of landfill by 2025. It's a huge lift, but we're on the way to do it. The next slide is about direct emissions from mobile combustion. And it's not a big slice of the pie. We have the same metrics that Caselli has. About 10% of the emissions are from transportation. So, and that kind of plays into the industry standard. And we made a huge play to go to CNG, compressed natural gas, which is about 80 on a carbon intensity, where diesel's 100. So we're off the bat, that's pretty good. But now we're making our own RNG, renewable natural gas, from dairy, wastewater, standalone anaerobic digestion. By 2025, we should have 119 million diesel gallon equivalents produced by 2025. That could take care of 13,000 trucks. So we have this platform in place to go after methane. It's the last thing we do to bend a climate curve, you know, and it's a short-lived climate pollutant. Over a 20-year period, it's 80 times more powerful than CO2, not 100 years, because it's short-lived climate pollutants and does its damages in 20 years in the near term. So that's a great tool to go after. We're well on our way with our carbon negative fuel, and we could easily have this a carbon negative solution. But our district in California, everybody wants to go electric vehicles. And I'm the guy who has to stand up that electric vehicles, zero emission vehicles, aren't zero. At a tailpipe, they claim to be, which they are, but on life cycle, the carbon intensity of our grid is about 34, 35. So it's not zero emissions, and you have to do the whole life cycle of the batteries, but they don't talk about that. But our sector, the waste sector, we're all in on diverting organics and making RNG to fill our trucks that are CNG for our 15,000 fleets. But now with battery electric and the heavy duty sector rearing up, they're shifting gears to go that direction. California, which is too bad because we have the perfect mousetrap. But we could be carbon negative if we continue this program, but we are demoing some electric, but they don't have the duty cycle, the infrastructure in place to do that until 2035. Next slide is about the exports. We exported about 15.8 million tons in 2018 on shipping emissions. The marine shipping industry hopes to reduce our carbon intensity of their fuel by 40% by 2030. So they're going to be reducing their intensity, but meanwhile, we're going to have a lot more export. China cleaned up, you know, China put us on notice. Our exports dropped from 22 million in 2012 down to 14 million in 2017, and that was piping back up. Our MRFs are making cleaner feedstock. You know, it was needed to make a better feedstock, so the export market's on a rebound with pricing and numbers. But with that, we're going to do another 9 million tons that will be exported, mostly plastic and fiber. We keep metal and glass and metal, but we keep glass local. But that export, about another 8 million tons export, will increase the volume, but with 40% less carbon. So that's so much shipping emissions. And I'm double counting that because it should be in the federal EPA WAR model, but it's not transparent enough to read it. So I just double counted and made a cool graphic about exporting our recyclables. And that's not really that's a global circular economy. It's not the local circular economy that we can do with organics, where we can't export organics. We feed the hungry with edible food recovery programs. We feed the soil with compost. We feed the tank with RNG, and we feed the grid with renewable power, all out organics. Next slide is scope 2 from imported electricity. We can easily cut that further down. We're going to cut it in half, but a lot of our material recovery facilities have solar on a rooftop. We're making biomass gasification plant that are up to 3 megawatt out of urban wood chips with that good pricing of the biomass program. And plus we got biomethane, where taking anaerobic digestion, instead of putting it to the tank, we can put it to the local grid first. So we could be zero direct emission reductions by 2030 if we went all out. If we get better utilities and better interconnection with the utilities, which we are. So we can do better than that by 2030 by making our own power on site. So next slide is that, what is net zero? Great discussion by Caselli. 3.7 times in 2018, 9.9. I can't even sell this to environmental justice community and environmental groups in California. Somehow they don't believe all this, that we're still stuck on dirty diesel, direct disposal, and we're not. We came a long way. So with the scoping plant coming up, I'm trying to leverage the fact that the waste sector is not your grandpa's landfill anymore. It's we're carbon negative on our fuel. And on the next slide, I even try to sell this to the local community when I do projects. Is I call the next slide is that we have a lot of disadvantaged communities in the Great Central Valley where we have a great potential to use compost, but through our disadvantaged communities, there's a lot of local projects. Being an engineer on land use, I do a lot of permitting at the local level. So I try to say we're the zero heroes of zero waste because we're net zero now with greenhouse gas reductions. We're 3.7 times. So that's good on greenhouse gas. Then we're getting off diesel. We were told to get off diesel 20 years ago. So we made the big CNG play and the carbon intensity is coming way down. And some of the gas that we're producing is minus 23, minus 100. And one project in Napa I have, we came up with a calculation minus 150. So we're definitely carbon negative because of the offsets from methane. And with our truck fleet, we also have the near zero NOx emissions from NOx, which is critical in some of our air districts in California. So we're knocking off NOx. We hope to go to zero waste, and by making organic compost, we're reducing a lot of pesticides. So the California Compost Coalition, we have a lot of clients that are organically certified through a couple different programs, so we're getting off pesticides. The dirty secret in California is that we had a statewide goal to be 75% statewide recycling by 2020. We didn't make it. A lot due to the export market. We had to re-gear our MRFs, make a cleaner feedstock. But in 2018, we were only 37% recycling, and in 2020, with COVID, was a weird year to how that's going to land. California hasn't calculated it, but we were at 50% statewide recycling rate in 2012, and now we're down to only 37% in 2017. So the waste sector, we kind of greening up disadvantaged communities. They don't believe me, but by getting off landfills, getting off NOx, getting off diesel, and doing net zero greenhouse gases with organic compost, we are greening your community. So that's why we have metrics. That's why I think it's a new industry standard you see with Recology, Waste Management, Casella, and that's why we do this net zero report. I'm happy to present it today and take some questions later. Thank you.
That's tremendous. Thank you so very, very much. And there's lots of great questions coming in, and I'm going to, I have to figure out how to stop the presenters here. Change presenter. Well, I'll make Terry the presenter. Terry, don't show anything. So, so there's questions. And Terry Goldberg, as I said, is going to lead that. I'm going to encourage our speakers to put their cameras on so we can see them, and also their microphones. And Terry, thanks for managing the questions.
Well, thanks, Lynn. This has been a great set of presentations, and it's nice to see how they complement one another. I just want to start out because Evan spent a lot of time kind of defining and trying to present a perspective on net zero. Abby, do you want to comment more on that concept from Casella's point of view?
Absolutely. Thanks, Terry. So I neglected to mention that careful listeners might have noticed that I didn't actually use the phrasing net zero. At least within corporate accounting, there is some sensitivity that is a defined phrase. And that they're pretty meticulous about what gets counted and what doesn't. So I guess I'm going to point out two things. Others might have noticed that I didn't talk about scope 3 at all. So we have quantified our Scope 3 emissions. We did that screening exercise last year. But our understanding, based on our read of the GHG protocol and the guidance for corporations doing their Scope 3 accounting, is that the stuff that I laid out in our net climate benefit factor doesn't qualify to be counted as Scope 3 under the GHG protocol. And similarly, the way folks are thinking about net zero in a corporate goal setting context, a lot of the stuff, it's unclear to me. I think that, I'm awaiting further guidance to see if any of that would qualify for a net zero accounting. And keeping a close eye on the Science Based Targets Initiative and their work around defining net zero to see how that all shakes out. But I just wanted to throw that out there, with that, as we all learn the new lingo and try to keep up with, globally how people are using the phrasing. We just want to be conscious. I think we're all talking about the same thing and working in the same direction, but sometimes the language catches us up. So just wanted to get that little disclaimer out there.
Thanks, Abby. So we do have a bunch of questions. We'll try to get to as many as we can. Going back to Anne's presentation, we have some questions about sort of how you account for food waste in the sort of, way you sort of talked about the different sources of organics and that kind of thing. So while the percentage of food waste has gone up, does that necessarily mean that the food volume has gone up, or is it just a percentage of the total? Is it just sort of the math, or is it real? And so what are some of the contributing factors that cause the increase in food waste going to landfill over the years? So sort of those two questions are related.
Sure. So let me take it from an emissions perspective first, and then we'll and quantity, and then we can talk about a little bit about why. So from an emissions perspective, landfills have default values that EPA presents to them on basically the organics entirely. Or if they want to do more work, they can go in and say, okay, this is the mix of waste we have, and then they have to be able to then apply different factors to each of them. And you might think that food waste would generate more gas than, say, paper, but it's food waste, if you think about it, is almost all, not almost all, there's a significant amount of water. And so the carbon content of food tends to be significantly lower. It degrades faster, but it's a lower carbon content versus something like paper and paperboard, much higher carbon content, lower degradation rates. So with that being said, we obviously are more concerned about what's happening sooner rather than later, because if we can push off the emissions for as long as we can, 100 years from now, less of a concern than the immediacy of that generation. So that's kind of a little bit, I think when I ran the calculations, it kind of almost balanced out the decline in paper and the increase in the food because of the speed with which the food was degrading versus how slow the paper was. But then there's fewer later emissions from the paper from the food because it's gone so quickly. That being said, why is food increasing? The generation of food actually didn't increase that much. You saw that the population went up significantly. We diverted a lot of our non-food materials, so paper and paperboard, fiber, cardboard, a lot of that got removed. A lot of yard waste also got removed as people developed yard waste programs. And so proportionally, the food just increased, and there wasn't the focus on food 20 years ago that there is today. And so that's really what happened. And you would expect if you didn't divert material, that your landfill quantity would continue to go up. Instead, it remained flat because you were diverting other materials. But it wasn't like universally the same mix of material got diverted. You were selectively diverting the material that were easier to divert. And obviously, there is a lot of focus on food waste as it grew in quantity at the landfill. People started paying much more attention to it, and we've seen that in the last 10 years. And there's been a lot of policies in various states on organics diversion.
Thanks, Anne. So here's a technical question. I think maybe Abby, you can answer. Does methane oxidation equal burning? Or is
sure
that
Anne
somebody?
could answer
Okay.
it too, but no,
Anne, maybe
it's
you can do that? Okay.
yeah, I'll pass that one to Anne. I know the answer is no.
Okay, go ahead.
No. So within the soil, so we have microbes. Obviously, everybody knows, you know, we're surrounded. So there's microbes in the soils. They're called methanotrophs. So methane is created by methanogens, which are a class of microbes that generate methane, so hence the term methanogens. But then there's another class of microbes that actually eat methane and convert it to carbon dioxide. So those are called methanotrophs, and they're basically, they like to hang out where the methane is. And so if there's a lot of methane coming through the landfill, then you know you're naturally going to have a lot of those methanotrophs in the soils. And so basically, there are microbes that convert the oxidize the methane into carbon dioxide.
Thank you. That's good. That's helpful. And what amount of emissions is captured in a plume for the flyovers? You know, where you were talking about the flyover.
Right. So what the flyovers that were done, they were done, they were not satellite flyovers, but they were actual airplane flights. And what they were able to do is in their plumes, they had a camera. I think it went from, I don't know what the lower level, but I think it went to like 4,000 parts per million. So if you see the mapping that they did, it went from like they said 0, but you know, obviously it didn't go all the way down to 0. There is some lower bound, but to about 4,000 parts per million. And then what they did was they basically extrapolated that out for the course of the year.
Okay. We're sort of pivoting to, as a question, to sort of more sort of broader, maybe policy. And so I don't know which of you want to take this on, but what do you think the future of landfills in North America are as states transition to more extended producer responsibility kinds of programs? I mean, how do you see that trajectory playing out in you know, either at Casella or other waste facilities in the East or the West, wherever? Anybody want to take that one on?
Landfills are forever. Yeah, they have too much permitted capacity, too cheap to meter. You know, that's one of the big problems. We can't get a lot of programs going for anaerobic digestion and composting because that costs 60, 80 a ton for covered compost, 80 to 100 for anaerobic digestion. Landfills on internal discounts are 20 bucks a ton. Billions of tons of capacity. So they'd be around forever, but they got to be maintained forever through different post-closure or maintenance programs. Federal EPA, I think, is 15. California, it's 30 plus forever. So there is always a role for compost. I mean, at landfill, and I co-locate a lot of compost facilities at landfills. They got all the infrastructure there. Trucks are going anyway. They got some borrow pits. So right now, I'm working on 5 larger compost facilities co-located at a landfill. So they have a lot of attributes. And another program, I'm trying to get the landfill guys to make a renewable natural gas so that the trucks are going there anyway. So we can take the RNG from the landfill legacy gas, fill up the trucks. Instead of going left to the landfill, you go right to the compost facility. So landfills are forever and they got to be maintained and great co-location.
And
so
I would agree with you, Evan.
On the sort of EPR piece of this and how that's going to affect the future here?
From the EPR perspective, obviously that is looking at specific packaging for the most part. It doesn't generally target some of the non-durable or durable materials that are landfilled. So there's always material that will require a final disposition location, and we need landfills to protect the environment. We need them to protect the groundwater. You know, I think any landfill operator will say, you know, we understand that the primary goal of landfill is to act as the final reservoir to protect the human health and the environment. So divert as much as we can, you know, follow the EPA hierarchy, do the reduce, reuse, recycle, and everything else. But ultimately, landfills are necessary until we find a final diversion location for every material. And, you know, obviously, every once in a while you see somebody on, you know, some news program that's brought their waste down to like this 1 cup of waste for a whole year. And, you know, I myself have gone through all sorts of machinations to try and reduce my waste load to that small amount, and I've never succeeded as well as those people have. But you know, there's going to be ultimate waste. And you know, as a recycling professional also, you know, one of the things that gets us all worked up is the amount of contamination we have, because people do so much wish cycling, and so we also don't want to encourage any of that by asking people to divert material that doesn't have someplace else to go, that doesn't have a final reuse opportunity.
I would just say, I would echo all of that and just say, you know, until we reach a point where everything is designed for recycling, for reuse, or reduced entirely, we should be thankful to have these landfills to contain these materials and protect the environment. I know it's not popular to say that, but it's the reality. Composters are glad to have a place to send their contamination. Recyclers are glad to have a place to send that contamination. They wish that stuff was going there in the first place. So it's a part of an integrated infrastructure, and it's going to be here for a while.
I will say that NUVOA did publish a report in the last year looking at landfill capacity, or disposal capacity, not just landfills, incineration as well, in the Northeast. And in the next 5 years, we're going to see significant declines unless there's more capacity built in the region. And in 10 years, very significant capacity issues if we don't have any increase in capacity, which will mean more waste shipped out of the region. So anyway, if you're interested in this issue, take a look at our report. It's on our website. So what makes a landfill unfit for gas capture? Getting back to some of the technical questions we're getting here. Anybody want to take that on? I don't know, Ann, you do?
For the most part, if there's organics in the landfill should be able to capture gas. If it's an inert facility that basically has taken ash or other materials where there is no opportunity, then it's not necessarily appropriate for landfill gas, because there's just no gas that's being generated. There's also the potential that it's taken, you know, organics. So sometimes Evan was talking about AD facilities. So an AD facility might take a lot of organics, but then maybe for one reason or another, contamination or whatever, that material after the methane is extracted from it isn't suitable for land application, then that might go to a landfill. But there's no real, that the potential for gas generation has already been taken out of the material. So those are the occasions where there's really not an opportunity for landfill gas. I'm wondering if the person might be asking specifically about the utilization, where there is a lot of candidate landfills that might be capturing gas but not actually utilizing it. Some landfills haven't taken advantage of utilization opportunities because early on, most of the utilization facilities had to be relatively large. But as time has gone on, smaller and smaller projects have become more viable. So there's always opportunities in the future.
And that federal EPA model has a default assumptions, like a lot of people, they got 25% fugitive emissions escape and 75% capture. That's all the industry standard science that people use, and you see that everywhere. But I think the super emitters flight showing a lot more than that. I think that the number will go up significantly, and landfills are weapons of mass disposal. You know, what I try to do in California, get a tip fee increase to help pay for the organic infrastructure. So, and so landfills, you know, are needed, but they need to be better controlled on their landfill gas. We're finding out through that NASA overflight study, and we look forward to harnessing that landfill gas to make RNG.
Okay,
I
Abby,
can speak to the
go ahead.
original question. So we do, we have gas collection and gas utilization at many of our landfills, and we do have still a few that are just flaring the gas. And it's usually because the grid, either it's too far away to the closest interconnect, or the local grid is maxed out and doesn't have capacity to take our electrons. To Evan's point, that's where we're looking at things like RNG, where we can, sort of move beyond, sort of leapfrog the local grid. I would also, I should mention, when in my read of the super emitters study, I don't think it's clear that it means that the 75% is an overestimate. I think the study was fascinating. I think it raised a lot of questions, and it'll be exciting to see what else comes from that. But I don't think by any means the conclusion is that 75% is an overestimate of gas capture.
I would agree.
So is the net climate benefit factor calculation that you showed, Abby, one that is accepted by EPA, or have you gotten feedback from them?
So it draws on EPA factors, and I try to adhere as closely as possible to what I understood to be, their approach to accounting for different things. But that said, it doesn't have any official stamp of approval from GHG protocol, EPA, et cetera. Any of these bodies. We're certainly open to considering that. We put it out there just as a starting point, kind of to start that conversation. So I would welcome. I hope I'll get some emails and some comments. I see Evan raising his hand. Maybe he's had some of those conversations.
Yeah, it is new science. A lot of people don't understand it, and at California Air Resources Control Board, which is pretty powerful and leading the nation on programs, they defined it, avoided emissions due to life cycle analysis. So the federal EPR WARM model is version 16 or something. I remember it's version 1 and 2 when I started this. And so that is a good basis of the best practices for modeling greenhouse gases for avoided emissions. So, and then we modify it in California for the energy mix and don't count carbon sequestering in the landfill. So, and we double count to be conservative, and we're still 3.7, but it's not embraced by CARB. Hasn't certified it. Nobody's certified it. What we did got certified are Scope 1 and Scope 2. The climate registry is a nationwide program, and our Scope 1 and Scope 2 emissions, not shipping, but all the fleet use and electricity has been verified by a third party. So we know Scope 1 and 2 are verified by a third party. And for the 100 calendar years I got certified by the climate registry, I always do Scope 3, California WARM model. And some of these companies are 10 to 20 times net zero. So net zero greenhouse gas is a term in California defined by the Air Board, and that means something.
Okay, thanks. So sort of related to these questions about emissions and counting them. We talked about how to prevent emissions through recycling, but so does the paper mill that buys your bales, right? I mean, and so how to avoid double counting when you're talking about recycling these materials? I don't know who wants to take that on. Abby, if you want to start with that.
I think, I spoke a little bit to Scope 3 and the fact that GHG protocol doesn't want us to calculate reductions achieved throughout our upstream and downstream impact. And I think it's because of that. I think they want to see that hit, to use the parlance, is category 1 of Scope 3 for the producers of products. They want to see the lower emissions of the products that they're buying because they're using recycled content. And that makes sense. And I think, that's fair. But at the same time, from my little position here in the Northeast, working with a company and advising on where we should focus our climate energy, our climate fighting energy, it would be crazy for us to spin our wheels on flares and gas collection. We want to do that, and we are doing that, but for us to ignore the role that we play in helping our customers, advance recycling and waste reduction would be nuts. So I think it's part of this is just sort of New England practicality. Like at some point, you gotta put the scoreboard up in the way that drives the right actions.
I agree. Everything Abby said, and we focus on Scope 1 and 2. We got direct emission reductions going on at landfills. That's the biggest hit. get 75% organics out of the landfill. That's great. On our fleet emissions, we can go carbon negative and near zero on NOx. If we allow to continue this program and don't get over-thrilled on electrification and battery electric heavy-duty vehicles that won't be around for a generation, but we keep on doing RNG where we're carbon negative, and we make our own energy on site with biomethane and biomass combustion and solar. So we can go direct emission reductions across the board, and that's important. That's verifiable. That's what's needed. And the scope 3 with the avoided emissions is avoided on a life cycle basis. And everybody wants to double count it, like wherever the bales goes, the local government says their bale double count. My MRF guy says it's his, so the operational area. So there is a lot of fraught for double counting, but the waste sector as a whole, we collect it. We have all these materials. It's a metric that we have from avoided emissions. It's defined by CARB. So I'm running with my scope 3 and call it net zero greenhouse gas emissions as defined. But the biggest focus is on direct emission reductions versus trying to fight over the scope 3 double counting. That is going on.
Right. Yeah, and I would agree. The focus, that's the reason why I spent all my talk on strictly landfills, because landfills is where the largest amount of scope 1 emissions are. That's where the bulk of the emissions are for the sector. And so by focusing on direct emissions, obviously we have reduced overall landfill emissions across the country by 35%, despite the fact that additional waste has been landfilled during that whole time, and despite the fact that landfill gas emissions occur over a longer period of time. I mean, we know we've reduced our emissions. That doesn't mean that we can't further reduce them, but we still have to look at methodologies for calculations so that we can work on improving those methodologies to reduce the emissions further, as well as to capture more and focus on the areas that were highlighted in that super emitter report that Durham published.
So we have only a few minutes left, but we do have a sort of question related to, some of these calculations. So for emissions from landfills, what is the global warming potential that Casella is using? Recent data shows that methane is a short-lived pollutant, and a 20-year global warming potential should be 80. This is more than double the global warming potential quoted by Anne. Is Casella considering this, and how does this change the denominator in the net climate benefit factor? Also, are you using the satellite data to correct your greenhouse gas inventory? So getting into some of the weeds here.
Yeah, absolutely. No, but I love the weeds. I can say, so we use the AR4 100-year global warming potential for methane, and that's just a function of comparability between inventories. We certainly consider the 20-year impact and think about what that means for the actions we take. Because, to Evan's point, it's sort of a near-term lever that we can pull to have a greater impact now. I will say some of our states are pushing in that direction as well as using the shorter-term global warming potential. But again, purely for sort of comparable greenhouse gas inventory purposes, we do use a 100-year potential. And no, we haven't factored the super emitter study into any of our calculations, because we are just purely for our methane modeling for the landfills, we are using the EPA, 40 CFR Part 98 calculation methodology, and we'll continue to do so for the time being. I don't know, Anne, if you wanted to tack onto that.
Yeah, to Abby's point, EPA's greenhouse gas inventory specifically uses IPCC protocols, which dictate which of the global warming potentials are used. So EPA follows IPCC recommendations, and so that changes over time. And we've seen the GWP change over time as IPCC changes, and that's why the assessment report 4 that Abby talked about, assessment report 5, will probably be taken into account at some point. But that's part of the reason why everybody uses what EPA says, because they've got the overall inventory, and if you want to be able to compare apples to apples, you have to go with that.
So
well,
we're done. I just want to say we do have some excellent questions that we didn't get to, and I'm sorry about that, but we are pretty much out of time. So go ahead, Lynn.
Yeah. Oh, thanks, Terry, and amazing job, everybody. Thank you to Anne and Abby and Evan. Very exciting and in-depth information. And Terry's right, there's a lot of fascinating questions hanging out there. So again, I'd like to thank our sponsors, Quantum Biopower, Tomra, and Vanguard Renewables. I have up on the screen, we have 2 upcoming webinars, one a week from today on recycling economic information studies, and one in early November on the non-organic percentage of material that goes to depackaging and what happens. So you can get to the registration links on the NERC homepage and on the NUMOA website. And yes, everything is being recorded and will be available. Yes, the presentations were being recorded and they are available. And with that, thank you to our audience and our speakers. Great webinar, and have a wonderful balance of your day. Take care, everybody. Bye-bye.
Thank you.
Thanks.
Bye-bye.